A 0.06 kilogram electrically charged ball hangs at the end of a string, oriented 50 degrees outward from a charged vertical plate. The E field produced by the plate at the position of the ball is 1 times 10 to the 5 newtons per coulomb, and points away from the plate. Determine the charge on the ball, sign and magnitude. Assume that the gravitational constant is 10 newtons per kilogram. So here's a diagram as one representation for which it shows the plate and the direction as well as the ball and the angle. And from here I used another representation, a force diagram, to make sure that the forces are equal in all directions because the ball is not moving. So for that I separated the string into two forces or two tensions in the x and y direction. And then from this force diagram you can use two equations that mg will equal tension in the y direction and the tension in the x direction will equal q times the E field. Because we know the mass is 0.06 kilograms and the gravitational constant is 10, you can plug that in to find 0.6 newtons, which would equal F sine 37 degrees, or cosine of 53 degrees. And in the same way, you can figure that Q times 10 to the 5th will equal F cosine of 37 degrees, or F sine of 53 degrees. Based on this, you can solve from F in this equation and plug in that same value here, and by using simple algebra to divide by 10 to the 5th power, you can solve for Q, which in this case is 7.96 microcoulomb.